Rahim. Assalamu alaikum, dear students. This is our next problem. Problem having been once again chosen from the same book which we are following for last about at least 50 videos. Okay. The book Modern Physics by Kenneth S. Crane. Modern Physics by Kenneth S. Crane. As usual, we first come to its statement. The ground state energy of an oscillating electron is 1.24 electron volt. How much energy must be added to the electron to move it to the second excited state, the fourth excited state? Okay, so this problem has two parts. Okay, we have to calculate the energy which must be added, and the electron is to be moved from the ground state to the in the first part to the second excited state, and in the second part to the fourth excited state. Okay, the ground state energy of an oscillating electron is 1.24 electron volt. How much energy must be added to the electron to move it to the second excited state, the fourth excited state? Okay, so this problem has two parts. As usual, we first come to helping tools. Dear students, its helping tool number 1 has been shown in two versions. Okay, first version has been chosen from the same book which we are following, that is Modern Physics by Kenneth S. Crane, while other version of this tool has been chosen from the book University Physics by Young Friedman. Okay, Young Hug Roger Friedman. Okay, so according to tool number 1, simple harmonic oscillator energies are given as En equal to n plus half into h cut or h bar or h reduced into omega naught, where n is equal to 1 to 3 and so on. Okay, equation number 5.5. Actually, this 5.5 is a topic of fifth chapter. Okay, fifth topic of fifth chapter of book Modern Physics by Kenneth S. Crane. Okay, simple harmonic oscillator energies En equal to n plus half into h cut or h bar or h reduced into omega naught. Here h cut or h bar or h reduced is equal to h over 2 pi. Okay, now we move to alternate version of this statement which has been chosen from the book University Physics by Young Friedman. Okay, energy levels for a harmonic oscillator En equal to n plus half into h cut or h bar or h reduced into under root k over m. Okay, n is quantum number perhaps K or perhaps K dash, actually perhaps K dash over M. Anyhow, energy levels for a harmonic oscillator En is equal to N plus half into H cut or H bar or H reduced into under root K dash over M, where N is quantum number, H cut or H bar or H reduced is Planck's constant divided by 2 pi, M is particle's mass, and K or perhaps K dash is force constant. Moreover, omega is oscillation frequency, oscillation angular frequency, oscillation angular frequency, where n is equal to 0, 1, 2 and so on. Okay, equation number 40.46. Okay, this is chapter number 40 of University Physics Young Friedman. Okay, so here dear students, almost quite same situation as in Kenneth S. Crane version or Young Friedman version. Okay, now in tool number 2 is very simple, in which I have taken 3 snapshots from three different books, and the purpose of tool number 2 is only to ensure that this W-like symbol, that is oscillation angular frequency, is pronounced as omega. Okay, so now we move to this is Greek alphabet. The last column number 1 alpha, column number 2 starts from iota, column number 3 starts from rho. Okay, so there are 3 columns, and last row of third column says that omega, omega. Okay, this symbol is its capital letter case, and this W like similar to W symbol is a small letter case. Okay, so angular frequency, which is denoted by omega, is written has its shape similar to W, but it is enough different from actual W. And this W like omega symbol is its lowercase. If we write in capital letters, then it is its symbol becomes entirely different. Okay. For example, dear students, the alpha, a capital letter alpha is the A, and small letter is this symbol. Okay. So similarly, beta, capital B, and small this beta, gamma, this symbol, and then this symbol. Okay, anyhow, other version which snapshot has been taken from some other book. Here once again omega, this capital letter case and this small letter case. Then third version of Greek alphabets, here again omega this and omega this. Okay, anyhow, now we come to its solution in a formal manner. We know that simple harmonic oscillator energies are given as En equal to n plus 1 by 2 into h cut or h bar or h reduced into omega naught, where n is equal to 0, 1, 2, 3, so on. Okay, here omega naught is a oscillation angular frequency. Okay, the only difference between these two versions is that In one version, simply omega has been used as oscillation angular frequency, while in other versions omega naught has been used. Okay, so it does not make very much difference. Okay, we know that simple harmonic oscillator energies are given as En equal to n plus 1 by 2 h cut omega naught, n is equal to 0, 1, 2, 3 and so on. It is given that, what is given that ground state energy has been given. Ground state denotes E naught. Okay, after E naught, because n varies from 0 to 1, 2, 3, 4, 5, 6. Okay, so ground state is E naught, for which n is equal to 0, and then we have to calculate E1, then E2, E3, E4. Okay, here we will have to find values of En up to 4. Okay, that is to say value of n equal to 0 is given ground state, while we have to calculate E1, E2, E3, E4. Okay, it is given that E naught is equal to half h cut omega naught is equal to 1.24 electron volt. Okay, this is given in the statement. For E naught, because n is equal to 0, so we will not write 0 here. Okay, it will simply become half h cut omega naught, and its value is given as 1.24 electron volt. Okay, this implies that from here, if we keep h cut omega naught on one side, then 2 will be multiplied with the E naught, and value of E naught is 1.24. So h cut or h bar or h reduced omega naught will become equal to 2 E naught, equal to 2 into 1.24 electron volt is equal to 2.248 electron volt. 2.48 electron volt. Okay, it is given that E naught is equal to 1.24 electron volt, hence h cut omega naught becomes equal to double of E naught, that is 2.48 electron volt. Now our task is quite simple. We will put n equal to 1 and we will get E1, value of E1. Then we will put n equal to 2 and we will get value of E2. Then we will put n equal to 3 and then we will get value of E3. Then we will put n equal to 4 and we will get value of E4. Okay, now using E naught equal to n plus half into h cut omega naught, where n is equal to 0, 1, 2 and so on, and h cut omega naught is equal to 2.48 electron volt. We have E1. When we will put n equal to 1, then 1 plus half will become 3 by 2. Okay, so E1 will be equal to 3 by 2 into h cut omega naught, and we know that h cut omega naught is equal to 2.48. So we will multiply 2.48 electron volt with 3 by 2, and hence value of E1 will become equal to 3.72 electron volt. Okay, for calculating E2, we know that 2 plus half means 5 by 2. 2 plus half equal to 5 by 2. So E2 becomes equal to 5 by 2 h cut omega naught, and we know that h cut omega naught is equal to 2.48. So we will multiply 5 by 2 with 2.48 electron volt, and hence value of E2 will become 6.20 electron volt. Okay. Now in order to find out the value of E3, we will put n equal to 3, and hence okay, E3 becomes equal to 3 plus half. 3 plus half is equal to 7 by 2. Okay, 3 plus half becomes equal to 7 by 2 into h cut omega naught, and value of h cut omega naught is equal to 2.48 electron volt, and hence in order to calculate E3 we will multiply 7 by 2 with 2.48 electron volt, and hence E3 will become equal to 8.68 electron volt. Okay. Now in order to find E4 we will put n equal to 4, and we know that 4 plus half is equal to 9 by 2. Okay. 4 plus half is equal to 9 by 2 h cut omega naught, and we know that h cut omega naught is equal to 2.48 electron volt, and hence in order to calculate E4 we will multiply 9 by 2 with 2.48 electron volt, and hence E4 will become equal to 11.16 electron volt. Okay. So what we have done so far, value of E naught has been provided in the statement. E naught is equal to 1.24 electron volt. Okay, from that value we have calculated the value of h cut omega naught, which has become double of E naught, that is 2.48 electron volt, and hence further by putting n equal to 1, 2, 3 and 4 we have calculated the values of E1, E2, E3 and E4. Almost our problem has been solved. Okay. Now for second excited state, delta E, that is change in energy, is equal to E2 minus E naught. Okay. Dear students, here it is to be noted and it is to be kept in mind very carefully that in each case we will have reference with ground state. Okay. So here delta E will never be equal to E2 minus E1. It will be equal to E2 minus E naught. Now for second excited state, delta E is equal to E2 minus E naught. In the next step we have put values of E2 and E naught. Okay. Value of E2 we have calculated in the previous part of this problem, while value of E naught has been provided in the statement. Okay, so this difference becomes equal to 4.96 electron volt. Now for fourth excited state, delta E, that is change in energy, is equal to E2 minus E naught. Okay. Once again I emphasize on the fact that not E2 minus E1, not E4 minus E3. Okay. We have reference with ground state E naught. Okay. So for second excited state, delta E is equal to E2 minus E naught, and similarly for fourth excited state, delta E is equal to E4 minus E naught. Okay. So we have found value of E4 in the previous part of this problem. This is 11.16. Okay, 11.16 electron volt minus value of E naught is provided in the statement, which is 1.24 electron volt, and hence difference of these two becomes equal to 9.92 electron volt. Okay, hence our problem is solved completely. And we had to find two values. Okay, first value is 4.96 electron volt, while second value is 9.92 electron volt. Okay, and this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.